If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are building concepts on ellipse. Hope you have seen the basic level. So in the first lecture in the intermediate level for ellipse, we will be seeing the position of a point with respect to ellipse, and then we will see the condition of tangency. What should be the condition so that a straight line becomes a tangent to a parabola. Okay, then let's see this. Okay, the article is position of a point with respect to a ellipse. So you have a given a ellipse. So this is the ellipse given and this is the point P is given. So P can be this point, can be outside, can be inside, can be on the ellipse also. So you have to check where this point P, how we will check it. So you can see if the distance, if I draw a perpendicular PM, this meets at M and this meets the ellipse at P dash. So if your PM is less than, equal to or greater than this P dash M, then you can say something. If PM is less than, then you can say it is inside. If PM is equal to P dash M, then it is on the. If PM is greater than P dash M, that means P is outside. You can see here it is smaller, that's why it is inside. So if your PM is smaller, equal to greater than, that depends inside or outside. Less than inside, equal to on, and greater than outside. So that means your Y1, this length Y1, the ordinate of this point Y1 should be less than, equal to or greater than what is the value of Y at that position P dash. P dash P dash M is representing x comma y. If your x is x1, then what is corresponding y? So if you put you know what is your y, that is under root d square. So this, that means if you put x1, then this will be your corresponding y output. So in place of x, if I put x1, then only I will get this corresponding y. What is the y from the parabola? So you can think I am putting in place of x, it is x1. So if you bring it this side, this is. So if you put, what was the original equation, x square plus y square by x square by a square plus y square by b square equal to 1. So if you put the point here, and if it is less than 1, then it is inside. Same in case of circle also, in case of parabola, if it is less than, then it is inside. If it is equal to, then it is on. If it is greater than, it is outside. So in every case it was the same condition for all parabola, ellipse, now in circle, now in next you will get in hyperbola also. Okay. Now in case of, now next article is condition of tangency. So if you have given a ellipse and you have given a straight line, now you have to find at what condition it will become a tangent to this given ellipse. So for tangency, how we have solved in case of parabola, it should touch at only one point. That is the idea. If it touch at only one point, then it will be a tangent at that point. So you take solution of these two, that means you put in place of yx, you solve it, you get the condition. And your discriminant should be equal to, if you solve it, this is your solution. So x you should get only one value. For that your d should be equal to 0. Quadratic equation discriminant. So b square minus 4ac, if you do this one, I am not expanding this one. If you expand this one, something will get cancelled. Finally you will get this one. So this is the condition of tangency. I am directly writing from here. You can do it easily. C square equal to a square, m square plus b square. Now you can recall your circle, because ellipse is quite looking like a circle. In case of circle, these two are equal. What is the difference between ellipse? If your b and a equals, then it becomes circle. Because then major axis, minor axis will be equal, then it will symmetry. From the graph also you can see if this axis and this axis is equal, then it becomes a nice circle. In all dimension it will be symmetry. Here also if you take AA, so x square plus y square, if you A will be then LCM, we will go that side. Then it will be x square plus y square equal to a square. It will be a circle. So in case of circle, what was the condition? You can recall. Because in circle A and B both are A, so if you take A, if you take a square common, it is m square plus 1. Because in case of circle A is equal to B. That is the similarity between circle and ellipse. How you can change ellipse into a circle. If you make A and B equal, then it will be circle. So you can, there is some resemblance or some similarity with this circle condition. So once you know one tangency very clearly, then the next coming things, that is ellipse, hyperbola, there will be little extension of that. So you can recall all this. So this is the condition of tangency. So the equation to an ellipse, this is, if suppose this is your ellipse, that what will be the equation? So this will be the equation. Y equal to mx plus minus a square m square. You can see a is here greater. So whichever is greater, m square will come with that one. If circle changes, so it will automatically change. So that we will see in problem of when we are applying this one in numerical. So this is the condition. So you can see now if a particular slope is given, suppose slope 1 is given, this slope suppose given, this is the slope, suppose it is minus 0.2, whatever slope, it is falling slope minus. So with the same slope you will get two tangents, one at this point, one at this point. So from graph also you can see, from mathematical also you can see. If m is given, one you can take plus, one you can take minus. So with this given m, if a particular slope is given, any slope given, that will be tangent to this one. You will have two tangents of that same slope. If you give this slope, then you will have another one, you can see. So you will always have two parallel lines of same slope which are tangents to this ellipse. If you like the video, then press the like button and please give your valuable comments in the comment section.